Hey folks, my name is Ravish and welcome back to another video in the series of DevOps real-time interviews. Now, in today's video, we have a profile with us. So this person has a very good experience in Kubernetes, Terraform, AWS and shell scripting. And this was a long interview, so I have taken an excerpt from it. So this interview would be concentrated more on Kubernetes. And you will notice that at one point of time, it became more of a discussion instead of an interview. We were discussing on what are the things we have in Kubernetes, how to do this, how to do that, what we are missing, this and that. Okay, so this would be the one. And if you're new over here, I would like to request that please do subscribe the channel because that would really support me to create content like this. And if you are watching this video in a YouTube short and or a Telegram or an Instagram, please do check out the link for the full interview. All right, so without further ado, let's get started. Let's talk about the Kubernetes part and EKS. So, so I'll start on a very basic. Why do you think we needed container orchestration?
Okay, that's a very so it's a niche question actually. So why because most of the companies now what I seen is even though they don't need Kubernetes, but because of the fancy word of Kubernetes, everyone's saying that okay, I need Kubernetes. That's one side of it. Technically, if you ask me whether I'll be able to run the existing resource on outside Kubernetes, it's doable. It's not, but it have its own problem. Even I used very, plain easy to kind of, just Jenkins and SSH and installing those kind of things in 2011. Then eventually moved to Elastic Beanstalk. Then even, after some time start using the code pipeline, code deploy. Then move to ECS. Then move to EKS. So there is a if you ask me why containers, it's majorly because, as you said, okay, the main problem is okay, it works on my system, it's not working on
Hmm.
production. Those kind of things are a very regular scenario. If you worked on that particular era of time, like 2015, 2014, everyone says, okay, yeah, it works. This worked on my laptop, but when you push to production, you might miss to update a variable or you didn't push it properly. I copied this to an FTP server, just copy it from there and push it to somewhere else. So to avoid these kind of scenarios, so containers is not to be honest, it's not something new. It's there for ages actually. That's LXI and those kind of things are there for a long time.
Exactly.
But
Yeah.
when the Docker started this project, it's become very famous. And the main purpose is you have a container which contains all the dependencies to run your application. Let's say it's a PHP application or a Node.js. You have the Node.js versions, corresponding node modules, everything. It's a fully packed thing, so you can technically run it uh, on anywhere as long as you have the depend. For example, if it need to connect to a database, it need to connect to a database. But technically, the same image can be used in local development, staging, production, or pre-prod, whatever the environment you are using.
Hmm. Okay. I mean,
Yeah.
this is generally see whatever people will say that okay, ठीक है, it's a buzzword, right? And everyone wants to move
Yeah.
over there. In 2012 when I started, 2013 when I started, we used to have two physical machines, not even VMs, physical
Yeah.
machines.
Yeah.
We used to install stuff over there. I started from Hudson. It was not even Jenkins
Yeah.
at that time, and then I
Yeah, I
used to
remember
do
this.
stuff over there. I mean, things were happening before as well, but since it has improved, so like what my take is on why do we need container orchestration is like a lot of people have started moving with containers, right? Docker. So it just makes it easy. I mean, if something goes down, who will take care of that? Will go over there, start stuff, and this load balancing, scaling, updating, the concept of self healing that came. This allows basically application to run reliably in more of a dynamic environment. So
Yeah,
that's what my
but
take
one of
is.
the challenge
Yeah.
which I seen with this kind of environment, right? Not challenge actually. Uh, See, when I'm hiring, one of the main key challenges there are guys who actually started working from, let's say, 2020, 2021, like 2 3 years kind of guy. They started working directly on Kubernetes
Yeah.
and they have no idea like okay how the things are working. If I say, okay, can you update something in the Nginx, they know how to add the annotation. But if you have a static server and if I ask them to, okay, update something in the Nginx, they have no idea. what is a server block, what is a HTTP block, what is a location, and they have no clue like okay where to change, what to change. But if I ask them, okay, I want this thing, they know where to put the annotation. That's one of the yeah. So I think you should, even though you are into Kubernetes, but you should know like technically what's happening in the background.
Exactly. I mean, a lot of people are going through the videos and stuff. Nobody generally studies books these days. I mean, I remember
Yeah, that's true.
I was in my engineering. I had a book called Gelvin for the operating system. I mean, that time I
Mhm.
knew about, okay, this is happening. What is the real time system? What happens over there? I used to study.
Same.
I mean, a lot of things are not used now, which is fine, but you at least have an idea. Just follow books for some time and then go for videos. But yeah, you were correct. In the
Yeah.
last 2 3 years, since Kubernetes is touching it, like the sky, a lot of people do not have information about that. But what to do?
Yeah, especially even the managed service itself. For example, let's say if I ask someone to create okay, I need a MySQL, they know okay, go to RDS and create something, or they know how to write the Terraform.
Hmm.
But if I have a static, I mean, if I have a particular MySQL version running on one machine, I ask, okay, I need a replica of this thing. Nobody know how to create a replica of MySQL. Nobody, I mean, the current scenario, nobody actually, I mean, it's not needed, but there might be some specific use cases. Okay, uh, I need a MySQL replica, but if we ask them, okay, they don't know how it works. They say, okay, go to console, create, okay, create a replica. It creates a read replica. Those, I mean, the managed services have its own benefit, but I think you should technically understand what's the I mean, how it's actually happening.
Okay, okay. Okay, so when we talk about the scaling part from the Kubernetes, how do you think they handle things when we talk about horizontally and when we talk about vertically? How do they do that?
So there are multiple type of scaling, right? One
Mm-hmm.
is on the port level scaling, which is actually HPA, the
Mm-hmm.
horizontal port autoscaler. So HPA takes care of the scaling of, I mean, the horizontal port autoscaler. I mean, the port scaling. But there are some other projects also which actually does this thing, like a KEDA, which is actually scaling based on, let's say, Kafka, or this kind of things. There are third party. I mean, it's I think it's a CNCF graduate project now. Or I think these are the main two things which I see. And if you are talking about the port vertical scaling, now there is a vertical port autoscaler, which is technically like, okay, for example, you have a two you put a resource limit of 2 GB and it needs a 4 GB RAM. Vertical port autoscaler can allocate that thing. That's one part of scaling, which is actually the port scaling. The second part is actually the you need to technically scale the nodes also to accommodate these ports. So which is mainly handled by cluster autoscaler. In case of in case of Kubernetes, mainly cluster autoscaler, and now Carpenter is also rising. So many people are actually switching to Carpenter for this kind, especially it's in the AWS. We tried it, but we face some limitations. So we are still stuck with the cluster autoscaler because the Carpenter, when we started initially, their normal behavior is they will try for the least amount. I mean, they try to run it in the lowest cost possible.
Mm-hmm.
So what we've seen is when we start scaling up, everything comes in particularly one zone because we are using a lot of sport instances in the production and scale. I mean, everywhere. So it all comes in maybe US 1C, 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 1C only. It's not actually taking the because maybe that particular zone have like the lowest spot pricing on the particular time. Everything is coming on that thing, which is actually breaking the purpose of the multi-AC kind of thing. And sometimes it don't know about the exact. I mean, there's a let's say there's a PVC which actually needs to go and I mean the EBS is in US 1A, but Carpenter doesn't know about this PVC. It will try to create a node in this region and it try to actually place the port there and technically start failing because I can't attach the volume back to the port. So we've seen this kind of issue. So we're still stuck with the cluster autoscaler. But maybe those things are resolved. I'm talking about 1 year back when Carpenter was zero point 0.6 or zero point 0.5. But not sure. I mean, maybe it might have already solved.
Okay.
So these are the main scaling parts in case of Kubernetes. Yeah.
Okay. So, I assume that you have worked a lot on this Amazon EKS, right? So, when we talk
Yeah.
about the high availability part and the tolerance part, so how do you think EKS ensures all of this high availability and fault tolerance?
So in case of master nodes, it's already, I mean, it's a managed service, right? So they already there are like it's they're running in the, I mean, the API service is in separate node. What is the thing? I mean, sometimes we lost the word, man. What is this thing? The one which stores the shit. I mean, basically, it's everything is in. It's basically a HA kind of setup in the data plane. Everything is sorry, control plane.
Correct.
Everything is, I mean, in case of us running with multi HA, I mean multi AZ, and in the same case with the, what is this thing? Sorry, I'm
Multi-AZ is correct. Multi-AZ deployment is one
yeah,
of the things that comes first in terms of when you
yeah,
do the multiple availability zones, because each
yeah,
availability zone should be a physically separate data center, independent power,
correct,
networking, cooling. So
correct,
that's
correct,
correct. You
correct,
were talking about managed control
correct.
plane.
Yeah, managed control plane. Yeah.
This is also correct. Can you
So that's what I'm saying.
brief me about it?
Where you want to go. So the API servers, I mean, see, it contains like multiple things, right? One is
Mm-hmm.
actually the API servers. I'm losing this word, man. What is where actually Kubernetes stores the state? Hey, sometimes you lost the word.
Are you talking about ETCD or
What is
something?
that? Yeah, yeah, ETCD. Yeah. So it is, yeah, actually, I mean, I lost the word.
Okay,
So sometimes it happens. Yeah, short term
it's
memory
it's
loss.
it's fine. Yeah.
So
Mhm.
yeah, yeah, so it's okay. So the etcd, I mean, everything is actually running in an HA kind of thing in their thing. And basically there, if I remember correctly, we created an ENI between the control plane and data plane, and that's how actually they're doing the communication between these, I mean, control plane and data plane, if I remember correctly. And how it ensures the availability, it's actually technically the same way how other things are AWS is managing it. So basically the it's running with a multiple API nodes, multiple etcd clusters, etc., etc. I don't know, is there anything else which I'm not sure of, but these are
Okay.
the primary things.
Okay, these two things are like pretty much common people talk about. Have you ever heard about this node group resilience? Heard about it?
It's actually on the data set. I mean, so you're talking about the cluster itself.
Mm-hmm.
So I mean, are we talking about the managed node groups, those kind of things, or I mean,
I mean anything that falls under this umbrella. So I mean my
node
idea of
group?
have you ever heard
Okay.
about it, node group resilience or something?
Node group resilience. I don't remember this exact
Okay, so
keyword.
basically, EKS, this will allow you to create managed node groups that run on your Kubernetes workload. So these node groups can be distributed
Exactly.
across multiple AZs. And this will ensure if an entire AZ becomes unavailable, your workload will still can function using another instances of AZ. So this is more of a
Okay. So
buzzword.
okay, we are talking about the managed node groups, right?
Node group,
So
yes, yes. So resilience is
yeah, yeah.
like a
Because
kind of,
see,
I mean, the word that I added, but it's more of a node group kind of a thing. Yeah.
yeah, yeah. Because I was thinking about the control plane part. I don't know, is there anything, because I thought, okay, you're talking about something in the control plane, but I mean, in case here, yeah, I mean, we have a managed node group. So even we moved to managed node groups very recently.
Mm-hmm.
I think maybe like 6 months back. Till that time, the primary reason was managed node group was not supporting the sport. I think till 1 year back, it was supporting only on demand on that time, and we are running a lot of sport across every environment. So we are not able to move on that time. And a few things, I mean, there are few advantages which I seen with the managed notebooks is actually, I mean, rollouting of the new AMI, which is actually quite smooth. Previously, we have to take care of a lot of things basically when we want to update the AMI of the CKs.
Mm-hmm.
That part is actually pretty much sorted. And the sport termination handler, which was actually we were running it in as a daemon set basically to handle. I mean, if any of the sport was terminating, but the after the managed notebook actually it itself is actually handling the eviction part, evicting the sport actually when the sport is actually terminating. So those things actually I seen, but I mean this particular keyword resilience, I never seen it. That's why actually I got confused. Right?
Okay, okay, no problem.
Yeah.
Okay, so when we talk about the load balancing part for the services across nodes,
Mhm.
okay, so how does
Okay.
Kubernetes manage this?
So basically, there are multiple. I mean, AWS support itself like three type of load balancers now:
Mm-hmm.
classic, ALB, and NLB. So by default, if I remember correctly, if in let's say the regular scenario, you're creating a service type load balancer, by default will try to create a classic load balancer. So that's one option. So in case of classic load, let's say I'm creating a service type load balancer. It codes actually the AWS API create a load balancer, and whatever the particular node IP will try to not IP, sorry, it will try to basically port forward to this particular port of this particular port. That's in case of a classic load balancer. Or let's say we are creating this as an Nginx ingress controller, and then let's say we have like five ingress controller running. It will try to basically port forward it to the node port of the particular Nginx ingress controller and try to divide the traffic. That's in case of a normal classic load balancer. The other option is actually now we have the ALB ingress controller, which also pretty much works in the same way. But instead of this kind of thing, it actually creates a target group and it manages in that way. And you can create NLB also, which also supported directly in the service annotation now. I don't think ALB is supported, but NLB and classic load balancer is supported, if I remember correctly.
Okay, I mean, my question was more of a like, we have the service load balancing, right? I mean, there is a feature that ensures the network traffic is evenly distributed to
Okay,
different
we are
instances.
not talking about the outside traffic. We are talking about the service itself.
Service load
Okay,
balancing I was
type
talking.
equal service.
S-
Okay. I thought, okay,
So
service,
just
and you're
wanted to
passing the
understand
annotation as a
how,
load balancer.
just wanted to understand how Kubernetes accomplished this.
Yeah, so basically, let's say we have a service, and I'm calling the service. There might be like, let's say, X number of ports in the service. So how service backend works is it uses the labels and selectors to basically route the traffic to corresponding ports. And internally, if you're talking, it's actually using IP tables to figure out what are the IP. It uses endpoints, and endpoints actually keep on updating the IPs of the ports to know like, okay, what are the particular ports IPs are actually available for the service to send the traffic. Yeah, based on the health, and once the health is passed, basically the endpoint will get updated.
IP tables is correct, but it's just a part. There are other things, other factors as well. I mean, a lot of
Um,
thing works in Unison. IP tables is correct. It's a part of it, but there are multiple other things. Any idea?
okay. I didn't get it. Maybe I don't remember. If you can just give me this thing.
Okay.
Will be because from my understanding, it's actually the endpoints, which is endpoints is actually sending. Endpoints actually get
Endpoint is
updated with
also a
the pod
part of
IPs
it.
when.
Endpoint
Yeah,
pods are
but
also
I
a
don't know
part of it.
which.
Yeah.
Yeah, I don't know which part actually I'm missing. So
Okay, so there is there. I think there are some load balancing algorithms as well. There is a specific algorithm written for Kubernetes used for load balancing, and this exactly might vary based on the Kubernetes setup and the service type that you use. Uh,
okay, kind of
huh.
a round robin kind of thing.
Exactly. This the
Okay.
first one is round robin, and there is one known as, I guess,
Yeah, there's least something. Yeah,
least connections, correct,
yeah, least
and there is
connection.
one known
Yeah,
as IP
yeah.
hash.
IP
IP
hash.
hash.
Yeah,
So I mean, these
it's.
are the one, and I'm
Yeah,
not
it's
sure
not
like,
using. We are not using. Yeah, we are not using it regularly, right? So that's why don't
yeah.
remember the exact keywords and the exact event. Yeah,
Exactly.
got it.
Round robin was the first when I was in. Again, the same thing. The OS book, Gelvin. I heard about round robin there itself.
Yeah. It's
That what exactly is round robin? What is this? So this is
it's it's
something.
it's technically, even if you are using an Nginx, just an Nginx, and try to run to like n number of backends, it also have the same thing. Okay, you can put the least connection, you can put the
Yeah.
round robin, everything in the Nginx configuration to figure out how to send the traffic back to the backends. Yeah,
Okay. There
correct.
are other things as well, but I just wanted to talk about this. Okay.
Okay. These kind of things are. We are not using it in day-to-day life, right? So, so when we talk about load balancing, this concept is very vast, right? We
Yeah.
can talk about the AWS level load balancing. Service type is a different thing, because I was not thinking that we are talking particularly about algorithms. I thought, okay, you just want to know how the traffic is actually getting split across every ports.
Okay.
Yeah.
Okay. Let's talk a bit about the ingress part. How do you think it facilitates external access to the services?
So one option is you can directly expose a service as load balancer. Let's say there's no ingress or anything in there. You can, let's say you have just one service you want to access, you can just expose directly as a service as load balancer. The other part is actually Ingress controllers. So, which is can be Nginx, traffic, whatever the things you want, HA proxy, everything support Nginx Ingress controllers now. So Ingress controllers, technically what it will do is it will create a service type load balancer, create a load balancer on AWS, and you can technically write the Ingress objects and route the traffic to corresponding services. That's it. For example, I have a domain like xyz.com. I can create an ingress with a host xyz.com slash and path is, let's say, slash route
Mm-hmm.
to specific deployment. That's it.
Okay,
And
okay.
if I want to have some specific annotation, for example, I want to forward from HTTP to HTTPS or blah 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 to blah blah blah, rewrite rules, all these things I can technically write as an annotation.
Okay, how does this path-based routing works in this scenario? We have host-based routing,
How
right?
it works in this? We can do, see, we can host a path based routing. For example, I have one host. Let's say
Hmm.
my host is dilip.com, and I
Hmm.
have, let's say, slash is going to my front end,
Hmm.
and I have a slash API which is going to my backend gateway.
Hmm.
So I can either I can add like, okay, two ingress object, or even in the same ingress object I can like, okay, add one more path like a slash API, and
Hmm.
I can route it to a different service. Service, let's say my backend service called backend API, and backend API port is 8080. I can route to a particular port. It's just in the ingress object. We can route to any path, any host. Or if you have like multiple hosts, you can pass an alias, or it's all doable. Yeah.
Okay, okay. So, since I think you're the lead in the team and you take control of the access part, if I talk about the how finely grained access control you can manage in EKS, specifically Amazon EKS clusters, how would you implement? What are the terminologies? What are the things that you're gonna take care about?
So you have to use technically RBAC
Mm-hmm.
properly to
First is
in case of AWS. Let's say we are specifically talking about EKS. Basically, what you can do is you can uh, attach an IAM role, and like,
mm-hmm.
for example, you have a specific port. Let's say I
Mm-hmm.
have a Jenkins port which I want to which should push to an ECR. Let's say I have this running in the cluster itself. I can't give. I mean, technically I can give the node level access to push to everything to ECR, but I don't need to do it now. But I can give a I can create an IAM role attached with a service account, and this service account can be linked to the particular deployment, and then whatever the IAM permission I given to that particular role can be actually used by the particular port itself. That's one part. That's actually on the service level. Okay, for example, I particular port want to upload to S3. I can give that particular permission on only to that port. Now
Mm-hmm.
it's built in supported by AWS itself. Previously, we used to use Cuba, AM, and all this kind of things to do this kind of particular scenario.
Mm-hmm.
The other part is accessing to the cluster itself. So accessing to the cluster itself, AWS manages via the AWS auth file. I mean, AWS auth, that's a config map if I remember correctly,
Mm-hmm.
or auth config. So there you have to specify what are the IAM users which actually want to access it, and you can technically give the corresponding, like, okay, what are, is it a master or is it a RBAC? I mean, you can give the RBAC level permission to even to specific users also in the cluster. I mean, in that file,
Mm-hmm.
you can mention what are the permissions required.
Okay. Have you ever worked or heard about this PSP, port security policies?
Port security policy, I heard of it, but to be honest, we are not using it actually. We used, so for some of the things we use the OPA and Open Policy Agent,
Mm-hmm.
but that's not actually directly related to this thing.
Mm-hmm.
For very specific user, but I don't remember exact user. It's been like a 1-2 years since we implemented, so I don't know the exact what all rules we have in the OPA right now.
Mm-hmm.
So we want to avoid some duplication of some services, all this kind of thing. That was the initial discussion, but it might be using for something else also right now. I
Okay.
didn't look much into that.
Okay.
Yeah,
Is it a third party tool? Because I've not heard about it, OPA.
it's a open source project, open policy
Third
agent.
party only, right? Not related to AWS.
Yeah, no, not a
Okay.
inbuilt Kubernetes object.
Yeah,
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 yeah.
I haven't heard about it.
So there are the yeah, no. There are multiple. One is OPA, open policy agent. There is something called KYVERNO, so which is also a policy enforcing. It's all CNCF. I mean, I don't know whether it's graduated or it's still in the maturing state.
Okay, okay. Never heard about it, but it's fine. So the part I was
Yeah,
talking about
yeah,
was PSP. So basically, we have this policy, security policies. This will help you to enforce the security constraint on those ports. And
yeah.
in this policy, you can define what are the security settings, such as allowed host, capabilities, namespaces,
Yeah,
and
I understand. I think this part we are actually currently doing via OPA, if I remember correctly. So, for
okay.
example, this shouldn't be allowed. For example, root access shouldn't be allowed to a particular port. I mean, the host level access shouldn't be there, or it shouldn't run as a root. Those kind of things.
Okay.
Currently, if I remember correctly, we are handling it through this one. It's basically just a under CRD. You just run it and you write everything in the YAML. Like, okay, what are the things allowed? So, for example, I already have a ingress with the name of Dilip.com. Then, let's say I try to create the same ingress with Dilip.com in any other namespace, it won't allow it. Just to avoid like duplication and those kind of things. So you can control this kind of. It's not just the port level, but it's actually you can use it for ingress and multiple purposes.
Okay, okay, okay. Uh,
Yeah.
there is one thing also I remember, namespace isolation, in which Kubernetes
Yeah.
namespaces logically isolate different application or teams within the cluster. So this is something I have heard. Not sure like how this works.
Like you're saying, okay, I want to give a specific guy access to a specific namespace,
I mean,
or
again, managing the permissions and resources it more effectively. So I've not done it, but heard about it.
yeah.
People do that.
Yeah, I mean, even in our case, basically the cluster level access is only with the, I mean, the cluster level full access is only with the DevOps team itself. Rest of the people are actually using, they want to, for example, if they want to check something, config Argo, I mean, most of the things are actually in the Argo UA itself. So if they want to know is the report cross, I mean, technically everything is going to the alerting in case of any port loopback or any specific pattern happen. It will go to the alerting, or even log level also we are using alerting. So in case a specific pattern happened for X number of times, it will also go to the Slack and alert everyone. Okay, yeah, this happened.
Okay.
Or in top of that, for example, somebody want to do a live debugging. I mean, the logs are going to either Elasticsearch or they might go to the Argo, and Argo from there itself they can from the UI itself they can see the logs. What's actually, I mean, the live time is available. So that's why we didn't give. I mean, as of now, it's only with a very limited number of people. We didn't have a. I mean, need to basically configure that kind of permission on the cluster level, because it's only like 7, 8 people are actually managing the cluster.
Okay.
So, and most of them actually need the admin privileges also to do the things. It's the DevOps team itself. Yeah.
Okay. Okay. I think this would be my last question for today. So we have this Kubernetes Helm, right? Uh,
Yeah.
what exactly it is and how does it assist in your managing the applications?
So Helm is I would say it's a template rendering engine. I don't know if that's the proper word, but you write. It's similar to, okay. You can treat it like how the CloudFormation for AWS, Helm is actually for Kubernetes. It's kind of the same way. You write whatever the things you want. You write the deployment object as a Helm, and you parameterize whatever the things you want in the particular template, and you use the values file or whatever the file to basically override any of the default value, and you can apply it. For example, the default, I write a Helm template with a deployment object, and let's say the resource limit is a variable in the Helm chart. The default value I put it as, let's say, 1 GB. 1 GB is the request, and 512 MB RAM is the. I mean, let's say 512 is the request and 1 GB is the limit. And in my case, I'm using this particular deployment object for, let's say, something more heavy. I need like more, so I can basically I can keep another values file for me, and I can technically change that particular part of this file and update the object. That's pretty much it. And if you want to talk about more about Helm, Helm as of now it doesn't have any other dependency. Previously, with the Helm 2, it used to have tiller to manage things. With the Helm 3, there is no tiller. Basically, it's the state is keeping in the etcd itself. Previously, there was something in between to basically for you to communicate back to the cluster. But Tiller have a lot of issues. Even we faced a lot of issues when we used Helm 2. But Helm 3 is, as of now, we are, to be honest, as of now, we are not using Helm 3 as the Helm 3. Why? Because the Argo current implementation doesn't support passing the values file as it is. So what we are doing in our pipeline is we are using Helm. We have a templates. The values file are actually in the repository.
Mm-hmm.
And when somebody try to deploy anything, it renders the entire file, like a deployment object, everything, and we are pushing it to a different repository, which where actually Argo listen to the changes, and it picks up from there and upload to the cluster.
Okay.
So for a developer, they think that it's a Helm chart because they're technically updating only the values file. For example, a specific application with like 10 ports, they just go and change them in replica on that particular repository. They go and change it. We render the template, update the Argo repository. Argo actually syncs back such changes. That's it.
Okay. Okay. Um, Anything on the release management with respect to the Helm charts?
Uh,
So basically,
are we talking about some?
uh,
Yeah, yeah, go on, go on.
when you install a chart using Helm, it will create something known as
Mhm.
release instance of that chart within your Kubernetes
Yeah,
cluster. So can you talk
yeah. I
more
mean,
about
if you
that?
do the Helm LS, it will show the release name and all this kind of things, right? Yeah.
So how does the Helm tracks it? Kubernetes tracks it. What are the advantages of it?
I don't remember exactly because, as you said, okay, as of now, we are not using Helm as Helm because we are just using it to render the template and applying it. So I didn't check much about it, to be
Okay,
honest.
no problem.
I
Okay,
mean,
so
we are
basically,
using some of the existing Helm template for example, to one of the some of the community Helm chart we are just using as it is, but rest of the things actually going by Argo. I mean, especially in our case, the Helm template is just basically to render the template and applying it on the question via
okay,
Argo.
okay, okay,
Yeah, so I
okay.
don't I don't remember those things exactly. Yeah,
No problem. I'll just brief it over. So when I was talking about like it
yeah, yeah.
creates a release instance of that chart within your Kubernetes cluster, and each release
Hmm.
is specific instance of your application deployment. So this can be versioned and you can manage it independently. This will track your releases,
Okay.
make it easy to
Yeah, you can
upgrade,
technically
roll
rollbacks and
back,
also
and
Helm rollback and yeah, yeah,
uninstall the
exactly. Yeah,
applications using the same. So this is a very
yeah,
brief idea about
yeah.
it.
Yeah, I mean,
Yeah.
I seen these releases and everything, but I don't know exactly. It's managing the etcd itself, right? I think it keeps these things in the etcd, and when you use Helm, it basically retrieves this. What are the version 1, 2, 3, 4? You can technically roll back to 2, 3, whatever the versions you want. Yeah.
So yeah, I think I'm done.